So greetings from Australia. Just got back from my second trip, going back for the third one in August. They really love the brain stuff, you know that? I think August will be my 17th trip to Australia.
Wow.
And it takes about 17 hours to get there. And I've worked so hard to get an accent.
They think you have one.
You're right. They do think I have one, but not the one I want. So the topic tonight is the power of sleep and what happens to your brain with sleep deprivation. Last time we talked, I think we talked about the power of water as your most important nutrient and what happens to your brain if you don't get enough water.
Pea brain.
And that's a pea brain for sure, but it's the tissue shrinks, you may remember, and it pulls away from the skull, and that is linked with dementia. No place I want to go. So tonight's topic, the power of sleep and deprivation. Pretty new research. I've only done this presentation a couple of times in Australia because the research is really new. And I like the new stuff, you know that. I mean, I like all the brain research, but I like the new stuff. All right, so Schopenhauer, I love what he says. Sleep is the interest we have to pay on the capital, which is called in a death. And the higher the rate of interest, and the more regularly it is paid, the further the date of redemption is postponed. Basically, what they're saying is this: sleep is independently linked with longevity. So you can be doing a lot of other really good things for your brain and body. And if you're not getting enough sleep, it is independently linked with how long you're going to live. 53, that's the new 33. Don't give me anything about 53. What you do to challenge your brain between the decades of 50 and 60 set you up for the rest of your life for a healthy brain. So I tell people, don't rush to get your doctorate, right after you get out of college. Your brain's probably not even done yet. Get a little work, get a little experience. If you want to go back to school, find something to study between 50 and 60, because that will really grow the little dendrites on your neurons and set you up for a much healthier longevity. So I expect Anita's not even halfway through her life. All right. I was talking to a researcher about sleep, and somebody said, I sleep like a baby. And the researcher looked at him and said, those who say they sleep like a baby don't have one. And I thought that was so cute. And those of you who have had one, maybe you slept like a baby, but probably wasn't the best sleep.
Ignore
Okay.
the crying baby.
Ignore the crying baby. Now, what is sleep? It's very complicated. I just spent some time with brain function researchers on sleep, and this is the way they're now describing sleep. It's not like a coma. It is a partially conscious state, but you can reverse it. So when you're in a coma, you look like you're sleeping, but you can't be waked up. With sleep, you look like you're in a coma, but you can be waked up. Sometimes with difficulty, depending where you are in which sleep cycle, because some of them are deeper than others, you still, at some level, your brain is aware of sounds and smells and, the old, what's that old fable about the princess and the pea? She's sleeping on 18 mattresses, and she said, there's a split pea under this mattress somewhere. So that supposedly made her eligible to be a princess, right? Well, so you're aware of that stuff, but not enough to really bring you to conscious awareness. And depending where you are in the cycles, it can take you a bit to wake up. On average, you'll sleep a third of your life. And if you're not sleeping a third of your life, you're probably going to have a shorter life. because the research shows that, at least in America, most people are as sleep deprived as they are water deprived. Like all of us, I'm sure, when I was much younger. You know, Anita and I are really holding at 39. But when I was younger than that, I used to think, man, if I could just sleep, you know, a little less, if I can work a little later at night and get up a little earlier in the morning, I can get so much more done. And guess what? Does not work that way. I need 9 hours at night. If I can't get to bed till 11, I still got to sleep 9 hours. So I really try to be in bed by at least 10. If I get 8 hours of sleep, I'll know it. The information just won't come to my brain like it usually does. I did get 9 hours last night, so don't get worried. But if I sleep 7, and you're used to hearing me make presentations, you'll know I didn't get enough sleep. Because I'll be saying, just a minute, what was I saying? Somebody remind me what I was just saying. You know, the brain just not clicking along because all of the tasks that it was supposed to do during those 9 hours did not get done because it takes 9 hours to clean my house and I only gave it 8 or only gave it 7. So if you've hired a housekeeper and they're going to take 8 hours to do your house and after 6 they say, I got to go. Well, 2 hours worth of work isn't going to get done. Or it'll all get a touch up, but it won't get done in depth. That's just like the metaphor for your brain. The 3 layers of the brain, I'm sure you've seen this before. This is just a cutaway of the brain showing the 3 functional layers. The first one's the reptilian. It's the brain stem and the cerebellum. Do I have I do. There we go. Thank you, Jason. I love it when I got a little something here to point with. Brain stem and cerebellum, reptilian layer, no conscious thought, but lots goes on there. The mammalian layer, again, no conscious thought, but a lot goes on there. And then you come up to the 3rd layer, the neocortex, and you've got some conscious thought here, especially right behind your forehead where your mind's eye resides. But most of it is still subconscious, 85% or so. And the research is if you can start bringing more to conscious awareness, then you can manage more, because you can only manage what you can identify, label, and describe. And I'm sure you've heard me say that before, and that's all about conscious thought. So sleep, brain stem, reticular activating system. It's the same system that sets your set point for whether you're extroverted, ambiverted, or introverted. And it stimulates the brain to wake up, and you have to block it to cause sleep. So if nothing blocks it like it's supposed to, you're going to have a really hard time going to sleep. And if it gets too blocked, then you sleep too much. It's a very, very sensitive balance system. The thalamus, which is the part of the brain when you take in sensory data, that's your triage nurse. If you went to an ER, emergency department. So sensory data comes in through the brain stem, it passes through the thalamus, which is a triage center, and it will send it to the right decoding area, if everything's going well. And if it isn't going well and it messes up and it sends visual data to your auditory cortex, you're going to start hallucinating because it'll try to decode it, but it doesn't have the code, and so it won't do it right. It contains what are called the sleep-on cells that block the RAS so you can go to sleep. So these 2 subconscious pieces work together just to let you even wake up or go to sleep. The hypothalamus is in the mammalian layer, and it's your circadian rhythm clock. And it's the one that tends to help you feel sleepier at night unless you're doing shift work, which is therefore like being jet lagged all the time. and helps you wake up in the morning. So it's also really critical. The reticular activating system down here stimulates the neocortex when it's trying to wake you up to make you alert and pay attention to what's going on. So you can see that sleep really involves the entire brain, and everybody's got to be cooperating. It's like a family, and if everybody's cooperating, everything goes quite well. But you get one family member that gets upset, and then things can deteriorate rather quickly. Your brain does not rest during sleep, and sometimes people have a really hard time understanding that. Well, I'm asleep, my brain must be resting. No, your brain is working harder at night while you're sleeping than it is working in the daytime when you are supposedly awake. In fact, parts of your brain are much more alert at night than they are during the daytime. Some of the functions that keep us alive, breathing, heart rate, blood pressure, fortunately they're just sort of the app in the background, keeping you going. And because we now have several different types of equipment, including brain scans, we've learned more about sleep very recently, really, than we have for thousands and thousands of years, maybe more than 6,000. Not going to talk much about sleep cycles, just to mention that there are two distinct types, and they combine and follow each other like footsteps all night long. The slow wave or non-rapid eye movement, and that's the longest of the two waves. It's characterized by large, slow brain waves, relaxed muscles, and slow, very deep breathing. That's kind of hard to get waked up from that. And then you've got the REM, rapid eye movement. That's the cycle that's much shorter, but it is the one where you can dream. And every healthy brain dreams, every night. But you may not remember it. If there is sleep deprivation, you're not getting what your brain needs in order to do all the housekeeping tasks, the intensity of this slow wave sleep increases, although the time is not going to increase. It just seems to be working harder. Most humans, it appears, start their sleeping with this non-REM sleep. And if you take a typical 8-hour sleep period, which is the average that most brains need, some need a little more, I need 9. One of my aunts just died, my mother's youngest brother's wife. She was 98 years old, still had her marbles, amazing woman. She slept 10 hours a night her whole life. That's what she needed, that's what she gave her brain. And I think, since we now know it's independently linked with longevity, I'm sure that contributed to her longevity. Some people need 7, some people need 6. Einstein supposedly needed 4, but he took it in a couple of different sections, so cumulatively he usually would get 8. So in a typical 8-hour period, you're going to go through 5 or 6 of these 90 to 110 minute sleep cycles, non-REM, REM, non-REM, REM, and so on. Newborns, by the way, if you're lucky, sleep about 16 or 18 hours out of the 24. And it's 50-50. It's half REM and half non-REM. But the REM sleep gradually declines in the amount of time. And by puberty, it's about 1/4 of the time, and by adulthood, it's about 1/5 of the time as compared to half the time of little newborns. Nobody is sure what that means, but that's what it looks like. Children age 7 to puberty need about 8 hours a night. Interestingly enough, teenagers need more than that. They need 9. but they often get less than 7. And during that sleep, not only are they doing the housekeeping tasks, but they're actually rewiring their brains. Because at puberty, the brains rewire. So that in adulthood, the male brain has a different wiring style than the female brain. So these teenagers, no wonder often they get involved with drugs and other things because their brain's not working very well because they didn't give it enough sleep. And they can't believe they need more sleep than, you know, their 7-year-old sibling. What we're seeing happen is this. Some of them are going to develop what's called a delayed sleep phase disorder, which means that the circadian rhythm system for that 24 hours gets pushed back. They're not sleepy till 2 o'clock in the morning instead of 10 o'clock at night. But then they can't get up for school. And even if they're on their feet, their brains aren't awake. And so they really do not learn because their brain's not working right. And then we get to adults, and on average it's between 7 or 8. And as I said, I need 9. The more exhausted you are, the faster you usually fall asleep. Now, depending what else you've done, you may not stay asleep. You know, if you've drunk alcohol within the 2 hours or so before you go to sleep, you're probably going to fall asleep quickly, but then you're going to wake up. Because alcohol is a toxin to the brain and it's going to disrupt your sleep cycle. Your brain's 2% of your total body weight, unless you're excessively obese. But it uses 20% of all your energy resources. And half of all those resources go to help the neurons talk to each other and transfer messages across the synapse. The brain virtually stores no oxygen and no glucose. It's true that the glial cells have a little bit of glycogen, but not much. So it's totally dependent on this regular blood supply of oxygen and high quality glucose and micronutrition and so on. There are some researchers that are really worried about this new push for a low carb intake. Because while your body cells can create glucose out of proteins, fats, and carbohydrates, the latest research is that the brain cells can only use carbohydrates. So low carb diets, researchers are wondering what are their brains going to be like in 50 years? Because the brain needs carbs. And it needs healthier carbs, not simple carbs. Not sugar and white flour and all the refined foods made with it. It needs healthy, complex carbs because it cannot obtain glucose from proteins and fats. Bottom line, if you don't get enough sleep, you're going to die, period. I mean, we're all going to die at some point, barring something amazing that we're not expecting. If you lose 1 hour of sleep a night consistently, you can shorten your lifespan considerably. I mentioned that your brain is busier during sleep than it is during the day. And if you cut it short, some of those housekeeping tasks will not be done, and waste products are going to build up in your house. Remember that mental exercise and its fatigue take longer to recover than physical exercise and its fatigue, which is one of the reasons that researchers recommend that you routinely get some physical exercise between long episodes of thinking, because that will help the recovery. What are the sleep housekeeping tasks that the brain needs to do at night? Well, it's going to restore energy reserves. Remember, the brain requires 20% of all the energy and it uses it up. It will process what happened during the past 24 hours, try to decide what the importance was, what it should move from short-term memory into long-term memory. And they're going to do that through dreaming that usually happens in that shorter REM phase. It provides the brain with special electrical stimulation to help with things like learning quickly, which is really important if you're in that 50 to 60 range and you're trying to build your brain structure so that you have a healthier retirement. It helps with memory. I mean, the hippocampus in that mammalian layer is just like the search engine on your computer. You want to remember something and it goes out and searches your brain. That takes a lot of energy. If you don't have it, you don't get a good search. Making decisions in your cognitive performance while you're awake. How alert are you? How cogent are you? How good are you at problem solving and creativity and so on? It consolidates information, things that you process that day, learn that day, and as I mentioned, move it from short to long-term memory. It repairs the cells in the hippocampus, that's your brain search engine in that mammalian layer, so that it can do that task. It helps to maintain homeostasis, balance, right balance in amount of glucose and so on. And it collects, you remember that the neurons don't touch each other, there's a space. It's called the synapse or the synaptic gap. It collects those transmitters, the neurotransmitters, because it doesn't want to waste them. So I think of them as, skin divers. Information comes down to the end of the axon on your neuron, and now it needs to cross the synapse, so it's going to talk to the next neuron. So little skin divers there, with packs on their backs, use the neurotransmitters to cross the synapse. And after the message is gone, they recollect all those chemicals and bring them back where they started from so they can be used next time. And that's critical for both norepinephrine and serotonin. And norepinephrine has to do with helping us solve problems and manage stress and think quickly, and serotonin has a lot to do with digestion, mood, and so on. If you don't collect it, there could be a problem. It reduces your body temperature unless you're sleeping really hot. It reduces the temperature and the level of metabolic energy so that the energy that you would have used to keep your temperature up now can be used for growing and repairing cells. So that's one of the reasons to make sure that you're sleeping in a cool room if possible. I had to get used to doing that because in Canada, when it's 56 degrees below zero, you're really not excited about a really cool room. And so sometimes we had to keep the temperature up a bit, but still my dad would always set the thermostat, the years finally when we had one, to be about 65 degrees, something like that, because we sleep better when we're cooler. So if you shower at night, don't end up with a really hot blast of water. End up gradually cool it down so that when you get out of the shower, it's almost lukewarm. Because otherwise it's going to take your body a long time to cool down. You're not going to go to sleep when you're hot. I feel sorry for the people who live in tropical countries and have no air conditioning. Actually, their lifespan is not as long, statistically, as it is in northern, more temperate countries. And that's probably partly because of the heat factor. It repairs the immune system cells. It makes new neurochemicals. They pruned all of those neurons out because you weren't using them. So that's one of the reasons that first 5 years are really, really important. Now this to me is fascinating. Here's a drawing of the synapse, and you can see that the little neurotransmitters are carrying information across here, and then remember they're going to collect that and take it back again. One of the things that happens at night is they flush this out, much like you'd flush out a hose, so that the plaques, those amyloid proteins that collect that are associated with Alzheimer's disease don't seem to collect. And that's a huge, important piece to do. It increases blood supply to muscle cells in your body, which is fascinating. No muscle cells in the brain, as you already know. But it will help the muscle cells in the body. Removes waste products from the brain, helps regulate appetite, mood, and libido. If you get stressed and tired enough, you're not going to feel like making love to your spouse. And if you want to get pregnant, you might not have enough sperm, or you might not ovulate right. Because when you lose sleep and get tired, the brain shuts down what it calls non-essential activities. Getting pregnant is a non-essential activity. Having sex is a non-essential activity. So here we find a couple that's really stressed, really tired, can't get pregnant. Duh. It creates, it's a chef. They act as chefs, these glial cells, and they create food called neurotrophins, which is the only thing the neurons really feed on. And it increases the production of a specific type of glial cells to form the myelin. You familiar with the term myelin? You know, you think fiber optics. It wraps the insulation around those axons so that the information can cross them up to 600 miles an hour. Sleep deprivation is a major risk factor for many disorders, including anxiety and depression, and you know that anxiety disorders are the #1 mental illness in the United States today. And they're calling it a mental illness because anxiety really changes the brain. Interestingly enough, if you get too little sleep, that's already been correlated with longevity, but if you get more than you need, maybe because you're anxious or depressed, bored, whatever. Interestingly enough, too much is going to increase your risk factors for heart disease, stroke, diabetes, kidney disease, etc., etc. So there's this band of balance that you need. Not enough, too much, very similar outcomes. The current studies on longevity, which I'm always interested in, show that the longest lived and the healthiest people, and now we're often talking about blue zone people, they get regular, restful sleep, period. This circadian rhythm is fascinating to me because we have 24-hour days. Somebody decided we should have 24-hour days. But the circadian clock is not a flat-out 24-hour clock. It's 24 hours in a few minutes. You know, maybe 24 hours and 7 minutes, or maybe 24 hours and 15 minutes. It varies. But if you did not course correct that all the time, pretty soon you would be really messed up because your 24-hour clock would be 30 hours or 34 hours or something like that. And you need solar light to keep synchronizing that clock back as close to 24 hours as you can get. One of the problems, and you've probably heard it advertised on radio and television, is what's called this 24-hour sleep-wake disorder. And it's usually found in visually impaired people, so that they're not getting enough light in through their eyes to the brain, and they don't synchronize their circadian rhythm. And gradually, it does not entrain, it's called. Does not keep moving back as close to 24 as possible. So they really have difficulty because there's no sense of this circadian clock, and it doesn't entrain. So, you know, they're wide awake at what's night for us, although they're not night workers. And they're really sleepy in the day when most other people are awake, and it can be a real problem. This clock, circadian clock, does not react well to rapid changes in light and dark. Meaning you want to sleep in a room that's as dark as possible. You want no electronics in that room that would emit blue or red light. And if you get up to the bathroom at night and you turn on the light, you're messed up. Because that clock now will try to reset itself. So I keep well hydrated, do not want my brain tissue to pull away from my skull. But I don't drink a lot of water the last 3 hours just before I go to bed, because I do not want to get up at night and turn the light on and wake myself up and then I can't go back to sleep. This is a problem with shift work, and it's a problem with jet lag. And in jet lag, you know, if I'm traveling from San Francisco down to Argentina, I don't have any jet lag. I haven't crossed any time zones. It's north to south. But if I go from here to Australia, or I go from here to Cuba, or, you know, I go from here to Hawaii even, the number of time zones that I cross will influence how much jet lag I have. Now, having said that, I have almost no jet lag because I've learned how to work with my brain. It's almost like I psych it out a bit. So the day before I'm going to travel, I try to alter my wake and sleep time closer to where I'm going. And when I hit that airport, my clock, watch, everything else gets moved to the time where I'm going. So if I have to be at the airport for 3 hours ahead, and then it's a 15-hour flight to Australia, that's, 18 hours difference. So at the airport, I will start living the time it currently is in Australia. So if I'm getting on the plane at 11 o'clock at night, well, in Australia, it's more like 4 o'clock in the morning, something like that. Can't remember exactly. I will not go to sleep right away. I will stay up, maybe the first 6 hours of the flight. And then I'll go to sleep. And when I wake up and get off the plane in Australia, I stay up all day, however long that is. No nap, nothing. Go to bed finally that night. And remember, I'm going to be very tired by then, so I always go a day early. But when I am very tired, remember that my non-REM wave doesn't get longer, but it gets more active. So by the time I have a really good sleep that night, wake up the next day, I'm in pretty good shape. My brain's opinion. So, here's the problem with a lot of kids and a lot of adults. You need to train your brain that you're going to bed at a certain time and you're waking up at a certain time. And for me, that's try to be in bed by 10:30, wake up at 7:30. If I have to get up at 6:30, then I'm going to go to bed at 9:30. Come the weekend, a lot of people want to stay up and play Friday and Saturday night. Okay, they've just messed up their circadian clock. So come Sunday night, they don't feel like going to sleep because you can train your brain in 2 days. And so Monday, they're going to be really sluggish. Hate Mondays. Well, I'd hate Mondays too if I stayed up late Sunday night and had to get up early. So you need to go to bed and get up at the same time on weekends as you do during the week. Once you get that, you really don't have any of this weekend problem. A lot of people don't want to do that. Want to go out and party Friday and Saturday night, have a terrible Sunday night. Monday and Tuesday are not really great at work. Shift work is a problem in America, I'm sure you know that. It really wasn't until the Second World War. Do you remember the stories about Rosie the Riveter? Didn't have evening and night shift work back then except for hospitals. But manufacturing needed help, and so all of these women were put on evening and night shifts, and they're given a lot of credit for helping production. But that started manufacturing saying, man, if we can work around the clock, just think how much more product we can get. Okay, that's true, but it's going to cost the people who are doing those shift hours. So right now, 20 to 40% of Americans are working shifts. Evening shift, night shift. And if they're doing rotating shifts, they're continually in jet lag. It's just like crossing time zones. So if you are doing rotating shifts, try to negotiate with your boss to pick one or the other. I don't know why they think. Maybe they think that they're doing a favor to the people who would ordinarily work at night by letting them rotate. 2 weeks days, 2 weeks evenings, 2 weeks night. They're doing them a horrible disservice. They would be far better off if they were working either evenings or nights than rotating, because that won't put them in jet lag unless on their 2 or 3 days off, they change their sleep cycle. But if they're used to sleeping 4 hours before they go to work and 4 hours when they get off, and you change that on your days off, you've just put yourself into jet lag. And 60 to 70% of these shift workers have a sleep disorder and are much more likely to fall asleep on their shift, which is not wonderful if you happen to be in the hospital and you need somebody to take care of you. They make more errors on the job. Many of the medical errors that occur in healthcare occur on the evening and the night shift with shift workers. And they've got lots higher risk for all kinds of things because their circadian rhythm is continually messed up. I'm sure you've heard of SAD, seasonal affective disorder, which really is related to that clock. When I was up in, let me see, where was it? North of Anchorage.
Fairbanks?
Not that far. Anyway, can't remember the name of that right now. They have the highest incidence of SAD of any place in America because there's so little light at certain parts. I don't know about Fairbanks. Would stand to reason it was the same thing, but the research, is about this one particular city. It's linked with substance abuse, suicide attempts, and so on. If you can talk the people into getting one of these natural light bulb things, several light bulbs, turn it on for an hour every morning when they get up and get that natural light exposure, because they aren't going to get it outside, their SAD symptoms usually dissipate. Before researchers knew that, they just have to hope they didn't kill themselves until the light changed again. And then their depression would leave. But a lot of people were killing themselves because they didn't get enough light. And who knew? I mentioned when we started that just like dehydration, sleep deprivation is considered pandemic worldwide, partly because of electric lights. Because before we had electricity, and you had those lanterns that, gasoline, whatever, candles, that was way too much trouble. So you'd pretty much just go to sleep and get up when the sun arose. But now that we have electric lights, you can stay up all night, but you're going to really mess up your circadian rhythm. 80% of the world's population has to set an alarm clock to wake up. And if you have to have an alarm clock to wake up, you are not getting enough sleep. Period. Common symptoms. Daytime sleepiness. This is the one that I don't like. Irritability. Can usually tell when you work with the same people over and over again who didn't get enough sleep last night because they're just so irritable the next day. And that's really gets old. Nervousness, don't manage stress well, they tend to do jot behaviors, they quickly jump to conclusions, they overreact, they take things personally, don't remember what you told them, and if they're kids or in school, not doing so good with learning, whether it's cognitive learning or behavioral learning or whatever. Diminished sex drive, increased risk of fertility, I've mentioned that. Frequent infections because their immune system gets compromised. Blurred vision. Do you remember you can get blurred vision from dehydration? You can get blurred vision from lack of sleep. Distractibility, increased appetite. If you don't get enough sleep, the research is that the following day you will tend to eat between 300 and 700 more calories than you would have eaten if you'd had a good sleep. Because the brain and body's tired, and it's trying to get your attention and says, I'm out of energy, and we end up eating instead of taking a nap, because we don't realize that that's really what the problem is. So weight gain and obesity associated with more than 50 chronic diseases can be also traced back to lack of sleep. Don't solve problems well because the prefrontal cortex is not working as well. Increased arguing, fighting, and conflict, well, because already they're irritable. Clumsiness, fall over things that aren't there. Cut off your finger, working in the shop. Car accidents. And increased likelihood for smoking and using alcohol.
Dr. Arlene, why is that one, the last one? Why is that?
Because smoking triggers acetylcholine in the brain, which helps you be momentarily alert. So if you're really, really tired, some people use that as their crutch to keep, they become chain smokers just trying to stay alert. And alcohol gives you a few moments of euphoria because it's a toxin to the brain. And the minute the brain's subjected to any kind of alcohol, it recognizes it as a toxin. It triggers the stress response, and it puts out enough brain chemicals to make you feel really good for a few minutes. But there's no brain on the planet that knows when you come to the point where the euphoria stops and now you get all the other deleterious effects of alcohol. Insulin resistance and diabetes. Obesity, high blood pressure, heart disease, and stroke. Prostate cancer. It's linked now to lack of sleep. We've talked about anxiety, depression, suicide, risk of Alzheimer's, infection, exacerbates attention deficit hyperactivity disorder, increases your rate of aging, shortens your lifespan. You take a flu shot and the vaccine isn't effective because the immune system's suppressed. And of course, memory and problem solving. Who knew? Who knew that just lack of sleep would put you in all these risk categories? 20 hours without sleep. Your reaction time is similar to that of a person who, in the state of California, has a blood alcohol level of 0.08. And the problem is that people think they're doing just fine. They don't get it. Sleep deprivation for 24 hours results in significant brain changes related to judgment, impulse control. Now you've got a brain that isn't even done yet. They're going out and drinking beer with their friends. They're losing sleep. No wonder that males up to the age of 25 are charged higher premiums for accident insurance. Everybody thinks they're functioning just fine. Thank you very much. Nothing wrong with me. When you are sleep deprived, the temperature of your brain increases. We didn't know that. And you tend to yawn a lot. And everybody thinks that's just telling you that you're sleepy. Well, it seems to be more than that. Yawning causes you to take in deeper breaths of air, and inhaling cool air ventilates your sinuses and helps to cool your brain off. So the brain is trying to keep you healthier, even if you haven't realized how to do that yourself. So let's finish up with a few sleep tips. Go to bed at the same time every night, as close to 10 p.m. as possible. It seems that the hours before midnight, according to some researchers, are critically important. So if you slept 10 to 6 or 10 to 7 or 10 to 5, if you needed 7, 8, or 9 hours, your brain would get more housekeeping tasks done than if you slept midnight to 7, 8, or 9. You'd get the same amount of sleep time, but it would not be as effective. Now, when I was younger, I used to say, all the way through school, I did my best studying from about 10 p.m. to 2 a.m. My brain was just wide awake. It probably was, but I have retrained my brain because I wasn't getting enough before midnight sleep. And it's amazing. Your brain can only do what it thinks it can do. And whose job is it to tell it what it can do? Yours. Sleep in a dark, cool room. Avoid rotating shifts if possible. And I've talked to people who said, oh, I can't do anything about that. You know, that's required at work. I just set them in with a few quotes and said, I don't care what shift you give me, just give me one shift. And most of the time they get it. Get all electronics out of the bedroom. They're putting out electromagnetic energy. Sometimes they got lights blinking and so on and so forth. It impairs the quality of sleep for everyone, period. And some people say, well, you know, what if my kids had an emergency and they were trying to call me and I don't have my phone in the bedroom? Well, what did you do before we had phones? If there was an accident, the police came to your door. You know, I no longer sleep with my phone in the bedroom. People can leave a message, wait, or come and bang on my door. But I'm not going to impair my sleep. Avoid eating after 7 p.m. so that your sleep is not impaired by digestion. Now, I don't know how they do it in Europe. You know, dinner in Spain and France starts about 9:30. I don't know if their 4-hour siesta in the afternoon compensates for that, but I try not to eat after 5 p.m. because I like stuff out of my stomach so my digestion's not keeping me awake. You know, the vagus nerve goes from your stomach right to your brain. And if your digestion is all grumbling around in there, it's going to be talking to your brain and it won't be a pleasant conversation. So you're going to be dreaming.
Yeah, in the Middle East, they have siesta time.
Some people think that siesta does make up for those late hours.
Because we work, when I was there, we work until 7. So we eat after that.
And they seem to survive. I don't know what the life expectancy is. You'd have to look at that versus people that don't do that. So
It's so hot there, that's why.
it is hot. Drink a glass of water before going to sleep. Now, I just said that I try not to drink a lot of water the 3 hours before I go to sleep, but I do drink a small glass of water before I go to sleep because I'm going to be not having water while I'm sound asleep. And that has statistically significantly decreased your risk of blood clots, especially if it's hot, because it helps to keep the blood a little bit more liquid. You may have seen these lack of sleep comics. I think they're really, really funny. This just happens to be one of them if you look for them in the paper. So here is this gal. She says, I separated all my dirty laundry from my dirty towels. Finally. Such soft towels. And then I was late to class. Not enough sleep. So it's a good opportunity to take stock of what you're doing. And I personally think, you know, I've told you that I take Delta E and Enterprime every single day. I personally believe that helps to keep my brain and immune system in balance so that I sleep better. I know that sometimes when I've been traveling and they lost my luggage, that I don't care if they lose my luggage now because I always carry my Delta E and my Enterprime with me on my carry-on. But they have lost my luggage a few times, and for 2 or 3 hours, days, I didn't have my Delta E and my Enterprime, and it made a difference in my quality of sleep. And the other thing is that people with hormone imbalance often have problems sleeping. And so that's one of the, if you're not sleeping well, you may want to get your hormones checked, because a dysregulation of hormones can impact your sleep. So everything's got to be in balance. So you all look like you're doing pretty well. You're still awake. Thank you.